Hello and welcome to this video on definite integrals. So far we've seen integration as the opposite of differentiation, allowing us to find y equals f of x when we know the gradient function f dash x. In practical settings, however, the most useful use of integration is that it finds the area under a graph, analogous to GCSE when you estimated the area under a speed-time graph using trapeziums to get the distance. However, if you knew the equation of the curve, you could get the exact area. Before we do this, we need to understand how to find a definite integral. In the example on the right, we are integrating 4x cubed between x equals 1 and x equals 5. In this case, x equals 1 and x equals 5 are known as the limits. The values of x we would be finding the area between, and you can see in the diagram that we're looking for the area under the curve between x is 1 and x is 5. We integrate as normal, but put the expression in square brackets, meaning we still need to evaluate the integrated expression using the limits. So we write the integral between 1 and 5, 1 at the bottom, 5 at the top, or 4x cubed dx, and then x to the 4 is the integral. That goes in square brackets with the 5 and 1 on the right-hand side. And then we substitute the limits into the integrated expression and find the difference. So we write a 5 to the power 4 in the first set of brackets minus 1 to the power 4 in the second set, because we're substituting into x to the 4, and then we evaluate the expression for each of the limits, top one first. So 5 to the 4 is 625, 1 to the 4 is 1, 625 take 1 is 624. Okay, looking at a couple of worked examples. In our first worked example, we're integrating x squared plus 1 between the limits of -3 and 3. The integral of x squared plus 1 is 1/3 x cubed plus x. We put that in square brackets with our limits of 3 and -3 on the right-hand side. Firstly, we substitute 3 into the expression, the top limit, to get 1/3 of 3 cubed plus 3, which is equal to 9 plus 3 or 12. Then we have our minus sign between the substitutions, and then we substitute -3. A third of -3 cubed plus -3 is the same as -9 take away 3, which is -12. And then finally we're doing 12 take away -12, which is 24. In the second worked example, we're integrating half x root x minus x over 4 between the limits of 4 and 36. But before we integrate, we need to rewrite the first term so it's got an index. So that's a half x to the 3 over 2 minus a quarter of x. Integrating both of those, we get 1/5 x to the 5 over 2 minus 1/8 x squared. Again in our square brackets with the limits on the right. We substitute in 36, and then we take away the same thing but substituting for 4. And evaluating or calculating what the answer is, we get 6944 all divided by 5. And notice in the box it mentions there's a button on a calculator you can use to evaluate definite integrals, but you should only be using it to check your answer. Another worked example, given that p is a constant and the integral of 2px plus 7 between 1 and 5 dx is equal to 4p squared, show that there are two possible values for p and find these values. So first thing to do is to integrate 2px plus 7, which is px squared plus 7x, put it in square brackets with our limits on the right hand side, and we're told that is equal to 4p squared. Substituting our limits, px squared plus 7x, when we put 5 in it, is 25p plus 35. When we put 1 into px squared plus 7x, we get p plus 7. So we're subtracting p plus 7 from 25p plus 35, still equal to 4p squared. And then by expanding the brackets and rearranging it, we end up with a quadratic of p squared minus 6p minus 7 equals 0, which factorizes and gives us the answers of p equals -1 or 7. And then one final worked example, given that the integral between 1 and k of 1 over the 4th root of x dx is 28/3, calculate the value of k. So rewriting the term, we get x to the -1/4, and then when we integrate that, adding 1 to -1/4 gives us 3/4, and divided by 3/4 is the same as timesing by 4/3. So the integral is 4/3 x to the 3/4, which goes in our square brackets with our limits of k and 1 on the right hand side. Substitute in k, substitute in 1 and subtract, and after a bit of rearranging we get 4/3 k to 3/4 is 32/3, times that by 3/4, and then we get k to 3/4 is 8. If we then find the cube root of 8 and do the power of 4 for that, we end up with 16 for the answer. Thank you very much.